So we'll get straight into session one. Our first speaker is Louise McNamara from Crop Science in Oak Park. And Louise's talk this morning is on BYDV impact and the impact of increased monitoring. And I would just encourage you, the first question is available on Slido now. So while Louise is going through her talk and maybe in between the segment of Louise into Sasha's talk, you can answer the question, please.
Okay, so thank you, Yoon. So today I'm going to give an update on our work on aphid monitoring and BYDV management. So first, what's the question we're dealing with? What's the problem we have? So there's over 25 different aphid species that spread BYDV into crops. The vectors we're most interested in is the grain aphid, the bird cherry oat aphid, and the rose grain aphid, because they're major vectors of BYDV in Ireland and Europe. They spread BYDV, which can cause yield losses of up to 80% with its severe infection, which makes it the most important insect pest and associated disease in cereal crops in Ireland. There's a number of challenges to controlling BYDV and aphids. Those are partial resistance to pyrethroids in grain aphid that we're all familiar with, but also the loss of insecticides. And further, we have to reduce our use of pesticides because we have pesticide reduction targets. Changing climate is a challenge because as winters get warmer, that can actually benefit many pests. And also there's no thresholds. So there's no robust thresholds for controlling BYDV that would help farmers use less pesticides. So the first challenge I'm going to talk about today is insecticide resistance. So we're familiar with the fact that there's partial resistance to pyrethroids in grain aphids, but what about the other main vectors? So the bird cherry oat aphid, there was concerns in Ireland that tolerance to pyrethroids had developed in this pest. So to answer that, we collected orpadi from a number of different counties, which you can see listed here. And we exposed those aphids to pyrethroids, so lambda cylohactrin, in glass vials to see if they were susceptible to the chemical. And we did it at field equivalent concentrations. And we also did molecular analysis on those aphids to see if there was any mutations for resistance. What you can see when you look at the LC50, which is here, which is the concentration of chemicals needed to kill half the population. You can see in red, that's the grain aphid we know there's resistance in, and you can see the LC50 is quite high. But if you look at the orpadi that's listed there from the different counties we sampled, you can see the LC50 is nowhere near as high in orpadi. So this study confirmed that there's no tolerance or resistance yet in orpadi in Ireland to pyrethroids, which is very promising for control, but we need to remember that as we lose chemistry, there's more pressure on pyrethroids, which means that resistance or tolerance could develop in the future. So we're continuing to monitor that. So as I mentioned, we know that there's resistance in the grain aphid, so we continue to monitor levels in Ireland. So how we do this is that we sample 50 fields across the country in the major tillage growing regions. So we sampled winter barley for grain aphids, and then we test them for a mutation called KDR, which is knockdown resistance, which confers resistance to pyrethroids. So in 2016, 2017, and 2018, this was done, and the levels of resistance seen in the populations range from around 50% to 20%. We were then interested, if the neonicotinoids were banned in 2019, would the levels of resistance go up as we lose chemistry, so there's more pressure on pyrethroids. So we did a study in 2021 and 2022, and I'm going to explain the results now. So you can see along the bottom of the graph, it shows the counties we sampled. In brackets, it shows the number of sites per county that was sampled. And on the left of each bar is the results from 2021. The right is the results from 2022. So what we saw was that in 2022, overall, there was higher numbers of aphids, and also there was higher numbers of resistance and BYDV in the aphids. So how you know that is if you look, the green is the aphids that tested negative for virus and negative for resistance. The yellow is the aphids that tested just positive for resistance, orange just positive for virus, and pink positive for both. So overall, what we saw was that in 2021, 2% of the grain aphids only tested positive for resistance, and in 2022, 35% of the grain aphids tested positive for resistance. And that will continue again this year in 2023. But our overall, what we've seen across these 5 years that was sampled is that while the levels go up and down, resistance is still widespread. and we've only detected partial resistance, so that's one copy of the mutation. So there's no full resistance yet, but that, again, can develop when we lose chemistry and there's more pressure on those pyrethroids, which would be very concerning if we had full resistance, because at the moment we're still getting control. So the next challenge I'm going to talk about is limited insecticide availability. So how do we control the BYDV and the aphids that spread it with the chemistry we have? So to look at this, we did trials in 2016 to 2019 in winter barley in Carlow and Cork, and I'm going to present some of the results. So we know from previous results in Teagasc that when you plant in September, your crop may require 2 applications of insecticides to protect from BYDV, and when you plant in October, you generally only need 1. So we wanted to know, was there an optimum timing to applying that insecticide for October sown cereals? So what you can see in this graph is the solid black line represents the yield from trials in Carlow, and the broken black line represents the yield from trials in Cork. And you can see across the top that this was done in 3 different years. The treatments we had was control, which received no insecticide, monitor, which also received no insecticide, but we took the aphids out of them to sample the pressure, early application, which depending on the planting date and the temperature ranged from late October to early-ish November, and late application ranged from the end of November to January. And what overall we saw was that for yield and BYDV, there was significant difference between spraying and not spraying. And for yield, there was no significant difference whether you sprayed between early application or late application. So both conferred control when the pressure was there. But in 2017, there was no differences seen because there was very little BYDV that year. So next, we wanted to look at controlling aphids and BYDV in light of resistance, the chemistry that was available, and also to confirm what timings are best. So to explain this trial here, explain this graph, you can see the red line is clethodim, which is the neonicotinoid seed treatment. And the green line is no clethodim, which is no neonicotinoid in the seed treatment. The foliar sprays we have, they're written in shorthand, but there's untreated here. LC stands for lambda-cylohydrin, which is the pyrethroid. S stands for sulfoxaflor. N is applied in November, and J is applied in January. So if you didn't get out in November, you applied in January instead. And just to show, yeah, so first if we look at just the seed treatment, so if you look in the box there where no spray was applied, there was a significant difference between no seed treatment for neonicotinoids and seed treatment for neonicotinoids. So applying a neonicotinoid significantly improved yield where there was BYDV pressure. If you added a spray on top of that neonicotinoid seed treatment, there was no significant improvement. So the seed treatment alone gave sufficient control of BYDV in these October sown cereals. Then if you look at where you didn't have a neonicotinoid seed treatment, because obviously now we don't, the green line, there was a significant difference between no spray and spraying, whether you sprayed in November or January when there was pressure there. So ultimately what we saw was pyrethroids applied in November and January led to a significant increase in yield in 2 out of the 3 years. It's 2 out of the 3 because there was no BYDV pressure in 2017. The same for sulfoxaflor. It also gave significant increases in yield. And there was no significant difference between using a neonicotinoid seed treatment or a foliar spray for controlling BYDV. So that's a good news story in that even though we lost the seed treatments, we didn't immediately lose control of BYDV. Obviously from next season onwards, we only have pyrethroids. So there's going to be more pressure on that chemistry, more chances of resistance developing and getting worse. So we need to be really careful to use resistance management strategies. Those include planting date being very important because you need less chemistry when you plant later in winter, and also monitoring and decision support tools, because using no unnecessary spraying helps protect the chemistry. But the challenge is we don't have these decision support tools or these thresholds to help us reduce the spraying safely. So to tackle that, we're doing work with Teagasc and Harper Adams to look at developing decision support systems for BYDV in Ireland. So to do that, we're looking at long and local distance migration of aphids to see if monitoring aphids can be used as a decision support tool. We're validating the Teagasc new Acrobat model for Ireland, which Sasha will talk about after me. And we're looking at how tolerant varieties can be used in Ireland to see if we can reduce our reliance on insecticides. So in terms of aphid monitoring, we have a new project called the AID project, which started last year. And we're looking at suction towers, yellow trapping in the field, and visual searching, so literally walking your crop, to see which would give a best indication of the pressure in the field to know whether or not to spray. And this started last year, and the monitoring will run for 3 years. So to give you an idea of what that kind of data looks like, I have some data on the screen here from spring 2022. And what we did that year was we had 17 sites around the country. You can see the lists of the sites there on the side of the graph. Farmers got 2 water traps per field. These are yellow water traps. And they sent in 2 to 6 sampling times to us in Oak Park. And we sorted the aphids, identified them, test them for virus, and test them for resistance. And you can see on the bottom of the graph there the average numbers of aphids found per field, and the colour tells you which aphid was found. So the red there is the grain aphid, and the yellow is the bird cherry oat aphid. So what we found in the yellow trapping in total was 61 bird cherry oat aphids, 7 grain aphids, 184 rose grain aphids, and 202 other aphids. So then we also do visual searching on the field. So that means literally walking the crop and looking at 100 plants per field. And this was done twice per season on 17 sites. Again, the sites are given the results in the same order as the last graph, so we got different numbers. And the total bird cherry oat aphids we found was 6. The number of grain aphids was 15. Number of roast grain aphids was 24. But the bulk of what was found was the nymphs, which is the offspring. So they're too small and they don't have wings, so they wouldn't be in the yellow trap. So this is a more labor-intensive way of searching the crop. So the goal is to do this in winter and spring for 3 years to see would either of these methods be a reliable way of farmers knowing whether there was pressure in the field to know whether or not to spray. We're doing other work tackling this problem. So we have the weekly aphid suction tower samples in 3 sites, and they feed into the Acrobat model we're testing from Teagasc. We have aphid MASH, which Virgile will talk about later, which is an assay that's been developed to speed up how we test aphids, which would support decision support tools. We're interested in characterizing BYDV diversity and improving how we detect BYDV to make it more specific and sensitive. There's posters outside on this if you'd like to read about this. We're interested in BYDV epidemiology, so how the disease itself works, and Max will talk about this later. And lastly, we're looking at alternative ways of controlling BYDV to insecticides. So that's endophyte trials, which is a type of biocontrol, and the use of tolerant varieties. And lastly, we're interested in how changing climate will affect BYDV in Ireland, so we can future-proof our control of BYDV into the future as climate changes. So this work was done by a huge team of people who are listed here. Thank you very much.
Thanks, Louise. So I'll invite you to have a seat here, Louise, and delighted to welcome Sasha White from Teagasc. And Sasha, who's an expert in this area, the title of his talk this morning is Seeking Better BYDV Treatment Decisions. So please start sending your questions in through the Slido app during Sasha's talk, and we will start to engage with those after Sasha's talk for a panel discussion. Thank you, Sasha.
Morning, everyone. It's a real pleasure to be here and to be able to talk about this work this morning. So I'm going to be talking to you about some research that we've been doing looking to improve treatment decisions in BYDV. I won't dwell on this slide too long because Louise has already given a fantastic introduction to the virus and its vectors, but suffice to say that in the UK, grain aphid has partial resistance, it's widespread, but because it's partial, it means that a full rate of a pyrethroid should still provide control. Now, our main challenge is deciding whether and when to apply foliar insecticides, because these are our only chemical control option available at the moment. And because pyrethroids are relatively cheap and the yield impacts of BYDV are potentially very high, there is an understandable temptation to apply in pyrethroids prophylactically. And if that results in increased pyrethroid use, That's bad for all sorts of reasons, but very pertinently because it increases the risk of stronger forms of resistance appearing in grain aphid and new forms of resistance appearing in Burcheri oat aphid. And if that were to happen, then control will be much more difficult. Now, at the moment, in the UK, spray guidance is essentially, if you see an aphid in your winter cereal, you might want to consider spraying. Now, that guidance hasn't moved on since the 80s, and clearly we need to be doing better. Now, AHDB, the levy-paying organisation in the UK, has provided some help. They've released a tool, it's their TSUM tool, which is essentially the same thing as Syngenta's BYDV assist tool. They do exactly the same thing. Now, essentially what this does is this helps growers predict when the second wingless generation of aphids are going to appear in their crop. And this is important because these are the aphids that are going to start moving out from those initially colonized plants to the neighboring plants, and that's when the widespread infection in the crop starts to occur. And on the right here, you can see a screenshot from that app, and it's really simple. Essentially, you put in your emergence date and where you are. So I've put in emergence of middle of September, and I chose a site down by Cork. And at the graph at the bottom here, you can see the blue line shows the accumulation of day degrees. And whenever that blue line reaches the top of the graph, that's essentially when those second wingless generation of aphids are thought to appear. And that's when the grower, the agronomist is advised to go out into the crop and have a look and consider spraying. Now, there's a few issues with this tool. So firstly, it does rely on crop monitoring. Now, this is something that's very difficult to do in the autumn. There's very low levels of aphids, there's low levels of light, and it's sometimes a big ask. The other thing is it assumes all of the aphids are carrying the virus. Now, we know from experience that this essentially never happens. Historically, in the UK, it's closer to 10%. Recent work, we've been finding it might be a bit closer to 20% of the aphids, but certainly nowhere near 100% of them. There's other couple of issues. So the origin of this model is unknown, and there's no real evidence it's been properly validated. And the last issue, probably the most important, is it too conservative? So this example here, this farm by Cork, essentially what this is suggesting is that you might want to consider spraying 5 times already this winter. And I don't think very many growers or agronomists would be considering spraying that many times. So really, what's the point of a decision support tool that's advising you to spray more than you consider doing? So a few years ago, AHDB and the industry came to us and asked whether we could develop something better. And that's what we've done. And I'm going to take you through the model that we've developed. And I'm just going to give you an overview of it. And I should say we haven't reinvented the wheel. What essentially we did is we looked at old models that have been developed, and we looked at updating them and improving them and putting them together. So the first part of the model is an aphid biology submodel. What this does is it simulates the arrival of the aphids in the crop and their population dynamics within the crop. And the input values for this are there listed on the right. So these are things like the aphids arriving into the crop, the daily temperature data, sow date, that sort of thing. Now I'm just going to touch a little bit more on that aphid data that needs to be put into the model. And this can be done in 2 ways. So you can either go into the field and monitor it and count the numbers of aphids that are moving in. As I say, that can be a big ask. But the alternative is the model can essentially use the numbers that have been caught in the local suction trap and predict what the numbers of aphids will be in the nearby crop, in the crop in question. But with Burcheri oat aphid, in the autumn, there's 2 forms of aphids that you might find in the suction trap. They look essentially identical. One form is migrating to Burcheri trees. We don't have to worry about those at all. The other form is migrating to cereals, and those are the ones we need to worry about, and those are the ones that the model needs to calculate. Now, fortunately, Harrington et al. Found a relationship that could predict the proportion of those aphids that would be migrating into the cereal crops, and that was based on the mean temperature of the previous winter. Essentially, what they found was that below 4.5 degrees, the proportion was about 10% of those Burcheri oat aphids migrating into cereals. But above that temperature, the proportion increased in a linear fashion. So we've included that in the model, so we've got a really good prediction of what the migration will be moving into those cereal crops. The second part of the model is a disease biology submodel. Essentially what this does is it simulates the infection of the crop with the virus. So the primary transmission, those first plants that are infected, and then the secondary transmission as the aphids carry out the virus into the neighboring plants and across the crop. Now for this, we need to know the proportion of aphids that are carrying the virus. Now, historically, this has been information that's been very difficult to get hold of. It's time-consuming. But our colleagues at Rothamsted, Martin Williamson, has developed a PCR that allows us to test aphids very quickly and get this information. So we've been working with them to generate that information for the project. The third part of the model is an economic threshold risk sum model. Essentially, what this does is it takes the information on the proportion of the crop that's infected with the virus, predicts the yield loss, and then makes a cost-benefit calculation to say whether going out and spraying is economically worthwhile. For this part of the model, there's a couple of input variables that we have, some information about where the crop is, its surrounding land use, and some information on the economics of the crop, so the expected yield, treatment costs, that sort of thing. And this is how the model fits together. So you have the aphid biology submodel that predicts the numbers of aphids per plant. That feeds into the disease model that predicts the proportion of the crop that's infected with the virus. And that feeds into the economic threshold submodel. And that outputs a range of things, so a risk to the crop, various other bits of information. But most importantly, it gives a spray recommendation. So you might want to go out and monitor your crop and consider spraying. Now, the model, I should say, so we've called the model the Teagasc Crop BYDV Assessment Tool, so Acrobat for short. And this is the input interface for this. So this is where you put in all the data that I've just talked about. It's really ugly at the moment because it's just a research version, but if we make it publicly available, we'll make it much more easy to use. So you put in all that data. In the bottom right-hand corner, that's where you run the model. And you can run the model as often as you like, every day, every week, every fortnight during the autumn and winter to get your spray guidance. Now, it's not just an apply tool. It can also be used for research purposes and to look at the effect of different scenarios. So I'm just going to go through one of these here with you now. So this is the effect of different proportions of aphids carrying the virus when they migrate into the crop. And it's a good indication of really what the model does. So what we have here is the proportion of plants infected with the virus over time. This is a crop that was sown in mid-September. It's a wheat crop. We've got 5 scenarios. At one end of the scale, we've got 100% of those aphids are virulifera's, carrying the virus. And then the other scenarios are lower proportion of those aphids carrying the virus. So at the other end of the scale, just 1% of those aphids carrying the virus. So when we look at the case where we've got all the aphids carrying the virus, that's the red line, we can see the rate at which the crop is infected is quite rapid. And you get a spray recommendation about a month after the crop is drilled. At the other end of the scale, where just 1% of the aphids are carrying the virus, the rate of infection of the crop is much slower, and that spray recommendation is delayed by about a month. Now, I was going to go through this scenario as well. This is a scenario looking at the effect of different numbers of aphids migrating. They can change quite dynamically from year to year, but just in the interest of time, I'll skip past this, and if there is time at the end and people want to, I can go back to it. Okay, so it's all very well developing a decision support tool, but as I alluded to earlier, it's critical that we validate it, that we check that what it's saying is sensible and that it's reliable. So we did this in the project. We had 15 tramline trials across 2 years. So a tramline trial, incidentally, is a trial where different tramlines are treated with different treatments. The trials are sprayed by the host farmer, and this was a really good way of getting feedback from them on how the model worked. And we had 2 forms of trials in these 15 trials. We had trials where sprays were recommended by Acrobat compared to sprays recommended by the T-sum tool compared to an untreated control. And then in the second form of a trial, we had sprays recommended by Acrobat compared to an untreated control. But then we also had a susceptible and tolerant barley variety in there as well. And on the right just shows a layout of one of those trials. So what did we find? Well, out of those 15 trials, only 6 of those trials actually had more than 1% BYDV symptoms. But of those 6 trials, in all of them, we saw significant reductions in BYDV symptoms where we used Acrobat compared to the T-sum or the untreated control. And there's just results from 2 of those trials on the right there. So at the top, we've got a trial from York in 2021, and you can see these are the percentage BYDV symptoms in the spring. And you can see that where we use Acrobat, we had significantly lower levels of BYDV symptoms compared to the untreated control and the T-sum. And at the bottom, This is a trial in Devon in 2021. This is where we've got a susceptible barley variety, that's Funky, and a tolerant barley variety, that's Amistar. And what you can see is, firstly, in the untreated, Amistar does reduce BYDV symptoms significantly. But where we use Acrobat, we also got significant reductions on top of that, both in the untreated and the tolerant barley variety. Now, we did see yield benefits, but there was only a single trial where we saw a significant yield benefit where we used Acrobat, and that probably reflects the relatively low BYDV pressure we had across those 2 years. And then lastly, Acrobat recommended half the number of sprays that the T-Sum tool did in 2021. Okay, so just to conclude, we've developed this new model, Acrobat. It uses a range of input data, but most importantly, the proportion of aphids that are carrying the virus. That's never been used before. It gave equivalent or better control to the T-Sum tool, but with fewer sprays, half the number of sprays. It can be adapted for other treatments if they were to become available, really relatively easily, but it does need validating under higher pressure. We're actually working with Louise and Teagasc to do that at the moment. And undoubtedly, there's elements of the model that can be improved. So for instance, at the moment, it doesn't include grain aphid, and that's obviously something that we need to work on and get into the model. So just to thank our funders and our project partners and all the people that are listed here who've had a massive role in the project, and also thank you for listening.
Thank you, Sasha. So Sasha, please have a seat, and I'll invite Kieran Collins to come up and join us on the panel as well. So we have a little over 120 people connecting in on Zoom as well, so please, people connecting in remotely, you're more than welcome, and we would encourage you to scan the QR code on the bottom right of your Zoom, of your screen, and you can input questions there. And I should say sincere thanks to Dermot and Shay on my right-hand side here, who are collating and moderating all the questions coming in on Zoom. So really insightful talks. Sasha, the Acrobat seems to be a decision support system that is showing potential. You mentioned especially with the tramline trials. And I suppose one question or one query I have is that you mentioned you have a low level of BYDV for those 2 years. So, I mean, would you have any insight as to how you would expect it to perform in a higher BYDV environment?
Well, I'm hopeful it would do a good job, but we just don't know. We don't know how. I mean, the predictions it makes, if we have stronger pressure, if we were to put that into the model, seems sensible. But whether those are enough to manage yield loss is it?
Yeah, and I suppose with any decision support system, it's about encouraging confidence for the growers in it, which is the key thing, and you mentioned that several times. So in regard to our question that's up on the screen at the moment, if you had a reliable DSS tool for BYDV, what would be the highest yield loss risk you would accept? A difficult question to ask if reduced aphicide use maintained aphicide efficacy. So Louise, I'm going to ask you you can see the poll here in front of us. What are your thoughts on it?
I think it's promising that the majority of people would accept a small yield loss, and I suppose like 10% would be considered very high. So I think it's promising because the reality of using a decision support tool, we know pretty well the timing of when to spray, and you know, we could put that out every year, and you see from our trials that probably 2 of 3 years it's significantly beneficial to put out a spray. But if we have to hit our reduction targets of reducing pesticides, we can't just put it out on the assumption that every year is going to be 2 of the 3 significant years. So the idea of a model is that it would tell us, hopefully, what is the 1 of the 3 years that would be low risk. But there's a risk associated with that. So if the model is too conservative, it does something like saying spray 4 times, which is worse than where we're at. But then if the model is too strict, it might not pick up those years where you would get subtle yield losses. So we have to find a balance, and we're not going to get it perfect because they're very complicated. As Sasha showed, like, it's not just temperature, it's wind, it's rain, it's the species of the aphid, it's all these different things. So there's a chance there would be some yield loss, but so it's promising that people accept that.
So it's all about mitigating risk, isn't it, Kieran? Because I mean, as Louise said, we need to know about aphid biology, disease biology, economic threshold, and I mean, as Sasha pointed out, when you ran the Acrobat model for Cork, it was suggesting a 5-spray program. So, I mean, Kieran.
Yeah. I suppose we're not going to get perfection. I suppose that's the first thing, and we do look for perfection. And any decision support system, it appears to me, is not going to give us that, and we have to build in an acceptable level of risk. I suppose, and it is heartening to see that people would accept some level of risk in the thing. I suppose from a practical or an advisory perspective, your concern is always that, I suppose, at the moment, we make a decision to spray, and then, if the advice comes in a direction, weather-wise or that, we don't. Whereas I suppose now what we're looking at is making a decision not to spray, and then relying on the decision support system to tell us when to do that. Yeah. And I suppose, again, from the practical side of it is we may not spray, then we get advice that we do need to spray, and then can we spray? You have the practical implications of weather. So then maybe our 2% yield loss increases to maybe much higher if we don't get out when we need to get out.
And yet it's going to be a very different mindset. I mean, it's a complete shift to what we have at the moment, what we would have experienced in the past. And yet we know from a farm to fork, sustainable use regulation that Stephen will talk about briefly later on, this is where we have to go and we have to support that. So, I mean, looking through some of the questions we can see here, how long before we can rely on the aphid count figures from the towers, Louise?
So yeah, you know that we have 3 towers and we do collect the aphid numbers every day, but we don't put the aphid numbers out yet because we don't know the best way to use them, and it's not much use to have information that you don't know how to use it. So we're testing that in 2 ways. One, as I said, we're putting it into the Acrobat model that Sasha has, and if that works, then as soon as we prove that, probably 3 years of trials will be appropriate. And then the other side, we are looking at, is the suction towers going to be the only way, or should that be supported by yellow trapping or visual surfacing? So would the suction towers be able to tell you the overall risk, and then you need to know for your own field? So probably it'll be 3 years of trials before we can say for sure, because we want to be able to say for sure first.
And also, I suppose the key thing is that, as Sasha pointed out, one aphid or not all aphids carry BYDV.
Yeah.
So there needs to be a change in the narrative in regards to that.
Yeah, it's not just about numbers, it's about the status of the aphid. Are they resistant? Do they have virus?
Yeah, so the question there, in any new DSS model, will it require input by farmers, agronomists about aphid numbers from the local area? I mean, Sasha, from your experience in terms of building Acrobat, I mean, you pointed out aphid biology, disease biology, but I suppose, it's a multifactorial requirement, so the more information you get, the better.
For sure, definitely. So no decision support tool is going to give you the right answer 100% of the time. It's not going to. You can't provide a model that can predict everything.
It's not perfect.
All the different variations. But it's a tool. We've got to see them as tools and to guide decisions. So input from farmers and agronomists is definitely there, and it's necessary. I mean, at some stage, it might be possible that if the tool is made widely available, that if farmers are inputting or agronomists are inputting data from their field, then that could be anonymized and people could see that and know what's actually happening in fields in their area.
So
but at the moment, people have to rely on those suction.
Okay, so maybe a cloud-based system where you can register for it and you can see what's happening at an environmental landscape. Yes,
I just wanted to add to that, like I think there's no substitute for physically getting out into fields and checking, because the decision support systems are, they're good, but they can't, you're going to get field-to-field variation, and we've seen that year in, year out. When you do get in, you'll see you won't find them in some fields, but maybe different locations, different, whether there's trees, humps, hollows, that kind of thing, the geography of it makes a big difference.
Very good. So, Kieran, this one for yourself, is there any research on the effects of rotation, nitrogen levels in crops? Maybe what are your thoughts in terms of the impacts of rotation and nitrogen levels in crops?
Yeah, I suppose the carryover from season to season would be the one where we would be finding where the highest risk is. Continuous winter barley, continuous spring barley. I suppose, new cap has kind of pushed us down the rotation road, which is good. But certainly the other one is the carryover of volunteers from season to season. Obviously, we're seeing that through the winter, especially when they're milder, and you can see the nymphs, even through the winter.
Yeah. So I'll stay with yourself. Aphid control in organic barley systems. I mean, it's open to the panel. Obviously, there are natural predators out there. Louise, you've done work on it, but
I would say that when you think of control options in general, lots of the IPM tools apply to all barley systems. So like it's
they're
not
system independent.
It's system independent. Like your planting date applies to everybody. Hopefully as more varieties come on the line, and then there's newer fields like the endophytes we're talking about. So using things like fungi and things like that to control them in a natural way. So there's cultivation. So there's options that apply regardless of your system that are not chemistry.
Yeah, Sasha.
For sure. There's varietal choice. Tolerant varieties are appearing. Green bridge management. There's possibilities of trying to interfere with aphid migration, trying to crop locations. So how they land on the crop. So can companion cropping, intercropping help, that sort of thing. So
the architecture of the crop itself in trying to get rid of that uniformity, not get rid of it, but change
it's the contrast. They land based on contrast between the soil and the crop.
Okay. So I guess it's further underlining the multi layers you need on this. There is no one perfect solution.
And the other one of the biggest things can affect BYDV risk is your drill date.
Yes.
You 1 month difference can have a huge effect on your risk.
Yeah, okay, thank you. So has any work been done on fields that have not had any insecticide use in the last 10 years? Do natural predators do the work of the spray? I mean, you touched on it there, natural predators.
Yeah, so not directly on that. I suppose as part of the 50 field survey I talked about with the resistance and virus levels, and there is a poster at that outside, you can talk to Max a bit more about that. Whether sprays or not are used on the field is recorded, and there wasn't the relationship directly between spraying and not spraying on the level of resistance or virus in the aphids in the field. But we haven't done any in-depth studies on no insecticide systems, I suppose.
Okay, so the second question, Louise, is specifically for yourself on seed treatment versus spraying. Wouldn't seed treatment, being highly targeted application, be much less risky to beneficial insects than spraying?
So I'd give you a number of comments to that. One, I don't look directly myself on beneficial insects. That's not my area of expertise, so I won't comment on which insecticide is best or least best for beneficial insects. What I would say is seed treatments have benefits and then negatives. In terms of benefits, you could see that you put it in once, your crop was generally protected, and you're not putting out those sprays when maybe beneficial insects are moving. But on the flip side, you have to put out your seed treatment before you know what the risk is. So that's almost prophylactic in its nature. So there's positives and negatives to both. I don't know if you...
Yeah, no, I totally agree. I mean, seed treatments are by their very nature prophylactic.
Yeah.
And we know in the UK that, that BYDV risk varies hugely from year to year and place to place. But nevertheless, I think seed treatment use, when they were available, probably didn't reflect that level of risk.
Okay.
So you could argue that actually, on a lot of occasions, those seed treatments aren't necessary.
So a bit of a sledgehammer.
Absolutely. And they do. Those neonicotinoid seed treatments, do have impacts on pollinators, and not obviously cereals don't pollinate, but if those neonicotinoids are picked up by flowering plants through the soil, then that can have an impact.
That's going to have an impact. Yeah. So, Sasha, the second question there. When is Acrobat likely to be available for use on farms? It's a tough one.
This is a big question. I mean, we are just finishing the project with AHTB now. So once the final report is in, which is very soon, then there will be a conversation with AHTB about the next steps. Certainly, we would like to take it on, and I'm sure. I don't see a reason why it couldn't be made available in Ireland.
And Louise, do you want to maybe expand on the work that you've planned?
Yeah, so we are testing Acrobat at the moment on both plot and tramline trials in Carlow and Cork, and we're going to do that for 3 years. But the caveat being that even if it works really well in the UK, we have to check if it works well here, because the main pest you're dealing with is the Burcherry O aphid. The main aphid we're dealing with is the grain aphid. So they have different biology and life cycle. So whether it will work for both or not, we don't know. Yeah. So that's why we have to test it. It wouldn't be directly used here just because it's used in the UK. We have to validate it for here.
Yeah, absolutely. Kieran, in terms of seed treatments or new active ingredients coming down the line, I mean, the mood music from Europe is that, in general, there's a pivot away from chemistries. Now, in saying that, on any IPM pyramid, the chemistry is there. It is still needed, but what's your insight?
I suppose, look, the targets are challenging, so we have to reduce anyway. And as you said, the IPM pyramid, we do need to protect what we have. So I think really that's where the work that the lads are doing really comes into its own, that, rather than prophylactic treatment, we obviously are going to reduce the level of resistance and that by minimising use, and that we do have that armoury, that when we do need to use it, that we can. And I suppose the other one, just on that is tolerant varieties, and I think that's an area as well. I know it's not directly related to what we're discussing here, but I think that will be a fundamental game changer when that comes through, and resistant varieties hopefully down the road.
Absolutely. There was a question there, Sasha, about economic volatility. I don't know if you saw it. It's popped off the screen, but basically, I suppose it's challenging in terms of how can we predict the economic threshold on something 3, 6, 9 months down the line. Now, I'm sure Acrobat is good, but I'm sure it's not going to be able to do that. But maybe it's linked in with economic modelling.
So this is the challenge. What it does at the moment, the model, is it says, based on your level of infection now, if the infection gets worse, and based on your treatment costs, then the yield impacts are going to be economically damaging. But if you start trying to predict what's going to happen, in 4 or 5 weeks' time, a couple of months' time, then you start having to make assumptions about what the aphid migration is going to be, what the temperature is going to be, and these things vary hugely from year to year. So it just brings in quite a lot of uncertainty. We could do it, but it does bring in more uncertainty.
Yeah. Well, I think it's like any model. The further you go out, the greater the variability in the answers you're going to get. I mean, that's the same for weather forecasting. Never mind BYDV forecasting. Louise, currently today, how much BYDV is in the winter sown crops?
In the crops, you can't tell when it's asymptomatic. You'd have to test it using ELISA or molecular methods, so I couldn't say how much BYDV is in the crops. And then in terms of the aphids carrying the BYDV, again, you have to test that all with molecular tools. So I couldn't say that.
So actually on that, I mean, we have, our Virgil will talk later on about this 3-in-1 assay. And we talked already about all the information that's needed. Kieran, I suppose, people on the ground might be thinking, I'm going to have to put a lot more time and effort into getting out there, walking the crops, seeing what's there, right? So, I mean, that's going to be a default, I'm assuming. We can do monitoring through Louise's networks, etc. But we do have to have boots on the ground.
Yeah, like I said earlier, I think there just is no substitute. We can get aphid numbers, and like the lad said, numbers don't necessarily mean BYDV. But like, if you do get out into your crops, have a look, see what you're finding. I suppose really that's kind of the key to it. And I suppose the other one is, weather is a big factor. We all know that, from the suction towers, if it's wet, windy, cold, you're not going to find aphids. So I suppose you're looking at weather patterns to guide you as well in the decision making.
Okay, so I'm just going to we have 2 or 3 minutes left. That second question there, and I'm going to ask Sasha and Louise, from your different perspectives, the effect of multiple applications of aphicides. It's obviously driving selection pressure. But so Sasha, from your perspective in the UK.
I mean, it's a big driver of resistance. It is the driver of resistance. There's multiple insecticide applications, certainly of the same mode of action group, which prethroids are. So, if we go from a system where we had seed treatments and a handful of farmers might then apply 1 spray to a system where suddenly we're considering 2, 3, 4 sprays every autumn, then that's a sea change, and and there is a long track record of prethroid resistance developing. In the UK, we've seen many pests developing resistance, so it's a real concern.
Yeah, and Louise, it's the same. You concur, obviously.
And I suppose I would say that we have to bear in mind when we look at the resistance level I was showing, that's when we had at least 2 chemistries, be it neonicotinoids or fluxiflor. So now, say if you sow in September and you want to put out 2 sprays, there is no chemistry to alternate. So we don't know yet how that's going to pan out, and there is high risk of things getting worse.
Okay, brilliant, excellent, Louise. Apologise. Basically, we have to keep to the time because it is a hybrid session. I want sincere thanks to Louise and Sasha for their presentations, contributions in the panel, and also Kieran as well for coming up. Thank you very much, and thank you everybody for your questions.